Now we're going to be solving some inequalities. And that's a lot like solving equations. We're trying to end up with x on one side and just a number on the other side. And just like solving an equation, you can do the same sorts of things. You can add the same thing to both sides. You can multiply both sides by the same number. There's one key difference. When you multiply or divide both sides of an inequality by a negative number, you have to reverse the direction of the inequality. You turn that inequality symbol around so it's pointing the other way. For example, let's say you have the inequality negative 2x is less than negative 6. To get from negative 2x to just x, you would divide both sides by negative 2. But since we're dividing both sides by a negative number, the inequality sign gets turned around so it's pointing the other direction, and it says x is greater than 3. So the numbers that x can be are all of these numbers over here greater than 3. Like, for example, x could be 5, and then negative 2x would be negative 10, which is less than negative 6. The idea is that when you multiply or divide by a negative number, that sort of flips everything around on the number line, so you're going the opposite direction. So that's the reason behind that rule for solving inequalities. Now, when you're doing the homework, pay attention to the directions. The directions in the books usually say something like, solve the inequality, then graph the solution set. And then on my assignment sheet, I made a little change to that. I said that you can either do this, that is graph the solution set, or you can give me the solution set in interval notation. You're welcome to do both of these, but you have to do at least one. Either graph it, show it on the number line, or give it to me in interval notation, or both, but make sure you do at least one of those. Now let's actually solve some inequalities. Let's work through some examples. Negative 4x plus 3 is greater than or equal to 7. Now if that were an equal sign, this would be an equation. We know how to solve those. So we're going to solve this the same way, but we're going to keep this a greater than or equal to sign. So first I will get rid of the plus 3 by subtracting 3 on both sides. Negative 4x is greater than or equal to 4. Next, to go from negative 4x to just x, I have to divide by negative 4 on both sides. But remember, when you're dividing both sides by a negative number, what happens? The inequality symbol gets turned around. That's why it's turned this way, and we have x is less than or equal to negative 1. So we've got our solution. X is less than or equal to negative 1. If you graph that on the number line, here's what it looks like. These are the x's that are less than or equal to negative 1. I've showed that negative 1 is included by putting like a square bracket right at negative 1 on the number line. And then as an interval, that would be the interval from negative infinity to negative 1 with a square bracket by the negative 1 to show that it's included. How about this one? 3x minus 5 is less than 6x plus 1. We want to get x terms on one side and constant terms on the other. So I could get x terms on the left and constant terms on the right by subtracting the 6x on both sides, and then getting rid of the minus 5 by adding plus 5 to both sides. So if I do that, I end up with negative 3x over here is less than 6 over here. The 3x minus 6x gave me negative 3x, and when I added 5 to both sides, the 1 plus the 5 gave me a 6. Now, to go from negative 3x to just x, divide both sides by negative 3, and we get x is greater than, because we turn this around when we divided by a negative, x is greater than negative 2. The other way we could have done this is we could have decided to get the x terms on the right and the constants on the left. So I could have subtracted 3x on both sides and subtracted 1 on both sides. Then I would have had negative 6 over here is less than 3x over here. Then go from 3x to x by dividing both sides by 3. Negative 2 is less than x. And this time I divided both sides by a positive number, so nothing flips. We didn't have to reverse the direction of the inequality sign. So it says negative 2 is less than x. Is that the same as what we got over here? Well, yeah. Either way, x is on the big side of the negative 2. Negative 2 being less than x means the same thing as x being greater than negative 2. That means x can be any of these numbers over here. If x is any of these numbers, then it's greater than negative 2, and negative 2 is less than it. So that would be the interval from negative 2 to infinity, with a round parenthesis by the negative 2 because it's not included. X can't equal negative 2, just anything even a little tiny bit bigger than negative 2. How about this one? Negative 3 times the quantity x plus 2 is less than or equal to 11 minus 4x. Let's start by removing the parentheses. Distribute this out and we get negative 3x minus 6 is less than or equal to 11 minus 4x. Now I can add 4x to both sides and add 6 to both sides, and I get 1x, or just x, is less than or equal to 17. There's my solution. X is less than or equal to 17. So it can be any of these numbers that are less than or equal to 17 on the number line. We are including the 17. Show that with a square bracket. And as an interval, this would be the interval from negative infinity up to and including 17. Oh, fractions. 1/3 x minus 1/6 is less than 1/6 x minus 1/2. How can I kill those fractions? I'm allowed to multiply both sides of that equation by the same thing. What thing can I multiply by that would kill off all of those denominators? I need something that's divisible by 3 and by 6 and by 2. Well, actually 6 would work. So let's multiply both sides by 6. 6 times the left side is less than 6 times the right side. So when you multiply that out, 6 times 1/3 would be 2x, minus 6 times 1/6 would be 1, is less than 6 times 1/6 x would just be 1x, minus 6 times 1/2 would be 3. So 2x minus 1 is less than x minus 3. Now I could subtract x on both sides and add 1 to both sides, and I would get x is less than negative 2. On the number line, here are the x's that are less than negative 2. And as an interval, that would be the interval from negative infinity to negative 2. Now here we have a compound inequality. It's got sort of 3 sides to it. It says negative 1 is less than or equal to 3 minus 2x is less than 11. So this is telling you that negative 1 is less than or equal to 3 minus 2x, but at the same time that 3 minus 2x has to be less than 11. So 3 minus 2x is between those two numbers. What does that tell you about x? What does x have to be between? Well, that's what we have to figure out. So when we are finished solving this, we should have just an x in the middle between two numbers. We have to figure out what those numbers are. So we're trying to get from where we have 3 minus 2x to where we have just plain x. And we'll start by getting rid of the 3 so that we have just the x term. To get rid of the 3, we will subtract 3. Right now it's 3 minus 2x. If we subtract the 3, then we'll just have the negative 2x. But we have to do the same thing to all 3 sides of this compound inequality. So subtract 3 from all 3 parts. The negative 1 minus 3 gives you negative 4. The 3 minus 2x minus 3 will give you just the minus 2x. And the 11 minus 3 will give you 8. So we have negative 4 is less than or equal to negative 2x is less than 8. Now remember, we want just an x in the middle. How do we go from negative 2x to just plain x? Divide by negative 2. So we're dividing everything on all three sides by negative 2. The negative 4 gets divided by negative 2. The negative 2x gets divided by negative 2. The 8 gets divided by negative 2. But wait! What do you have to do when you divide by a negative number on all the sides? You have to reverse the direction of the inequality signs. So they're going to get turned around. So negative 4 divided by negative 2 is positive 2, is greater than or equal to x is greater than negative 4. So x ends up being between the 2 and the negative 4, on the small side of 2, but on the big side of negative 4. X has to be less than or equal to 2, but greater than negative 4. So here's what x can be. Here are the numbers that fit that description. They have to be between 2 and negative 4. 2 is included. X could equal 2, but x can't equal negative 4. So this would be the interval from negative 4 to 2. Remember, for interval notation, we always go from left to right, smaller to larger. So we start with negative 4 and go up until we get to 2. We're not including the negative 4, but we are including the 2. I'm going to end this video here. In the next video, we're going to talk about absolute value inequalities. See you then.